Hello, my sweeties! Today we're going to be learning about my favorite lesson of math, which is actually not that hard. It's called common logarithms. Now, there are calculator portions in this in which I will teach you how to solve problems using a calculator. Those will be at the end of the video, presented in pictures. So, if there's anything that presents the need for that, you can skip to the back of the video. And don't worry, this is going to be a lot of fun. I'm pretty sure that we're going to have a lot of fun learning this. When you get it, it's really fun. So, again, F-U-N. Fun. Smiley face, heart. Okay, so I am now going to present to you the objectives that we're going to be going over today. Again today. Students will be able to solve equations containing common logarithms, and students will also be able to find common and anti-logarithms of numbers. Now, there's a typo in here between comma and anti. As I'm fixing it right now, you can kind of see. Fix it. There we go. Now we're going to learn the basics of common logarithms. Now, all the time, common logarithms are a base of 10. Even if there's no base present, it is 10. So this can be presented well in the equation logarithm 100 is equal to 2. As you can see, there's no base present, as we can see. Some people might actually mistake the 100 as the base, but no, the base is actually in between the log and the 100, and since we cannot see it, we know that it is 10. Now, I'm going to teach you a very, 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 very applied skill that is very important when it comes to common logarithms, and that is turning them into exponential equations. So, for example, we're just going to use that same little equation that we saw before. Say hello! He's back! Okay, so what we're going to do, easy peasy, we're going to switch the base of 10 over to there. And we're going to make the 2 the exponent. Easy as kittens. I'm just now showing you where all the numbers went, so that you guys aren't left in the dark with this. See? Okay, now we're going to talk about the rules of common logs. There's about 7 in total. Now these are very important, so I would write these down. You can pause the video to do so, because they're going to be applied in many of the problems in which we solve them. Okay, so practice time! Oh, that's so cute. Okay, so we're going to be solving the equation log 5 times 2 to the exponent of 3. Remember rules. Okay. So we are going to see 2 rules in this problem. We see not only multiplication, but also an exponent. So we know, so this is what's happening right here. Just to put it in a different form so it's easier to see. And we know that when it's multiplied, that it is added. The 2 logarithms are added, and the exponents go in front of the log. Now it's time to use our handy-dandy calculator. Yay! Calculators are so fun to use. Like I said before, it's going to be at the end of the video. So you can skip to the end. Don't worry, all the examples are labeled. Okay, so I'm going to teach you how to graph them now. Okay, we're going to jump right into this with the equation. Yeah, this is also another calculator, so this will also be in the back of the video. So, yeah, yay! Calculator's fun and easy. But now I'm going to teach you it by hand, because there are certain times when you will be asked to graph these by hand. Yeah, JK, whoa, we're not solving that. I'm going to give you guys an easy one. Okay, we're going to be solving y equals log x. Okay, first off, I would not start out with a table. I do not recommend it at all. Don't do this. Don't do this. Don't start with this. Trust me, we have an easier way of doing this. Just to exaggerate. Okay. So we know that this is equal to the base of 10. So, we're going to turn it in exponential form. And if you guys remember how to do that. Okay. So, you can plug in the numbers in and you will get that graph. So now we're going to be solving this. Okay, so I'm going to walk through this with you guys. So we're going to be solving log 6, the exponent of 3x is equal to log 81. So as we remember, exponents will go in the front, presented by the 3x in front of the log 6 is equal to log 81. And we're going to try to get the x by itself. So we're going to divide both sides by log 6. So, log 81 is going to be divided by log 6 is equal to 3x. And anything divided is equal to okay. Now, as we know that anything divided is going to correlate to the rule in which something is minused. Just to word that better, look at the rules. The logs that are divided are minused by each other. And we can use a calculator to get what these logs equal to. Oh, and don't forget to also divide by 3 on that after you've calculated that, which you can use a calculator. Which again will be at the end of the video where I will show you. Okay, so now we're going to solve this. It has a lot to do with kind of like the rules of scientific notation, if you will, which is my favorite part of logs. So log 7 is given as 0.8451, but we won't be interested in that yet. So we're going to be dividing. So we're going to turn this into that. And this is going to help us solve it. So just like in scientific notation, the zeros are going to turn into the exponent of 10 over 10. And that is going to be added because of multiplication to log 7. Okay, now we're going to remember our rules. So, these are new rules actually. So you might want to write these down, take some notes, because we're going to apply it to this problem. Okay, so what we did is we removed the logs. Oh wait, no, we used these rules, sorry. I know what I'm talking about. Okay, so we're going to be using the second rule that is presented, and that gives us that equation that we're going to solve. And if you just add the 6 and the 0.8451, you're going to get the answer. Yep. Remember, the 0.8451 is because the 7 was given. And that is going to give us this little beauty as our answer. Look at that figure 8. Beautiful. Can you guys believe I'm doing this with a mouse? Perfect. Now, using this, I'm going to send you off on your own to solve this problem. Now, don't be discouraged. It's basically doing the same thing with applying scientific notation. So if you know anything about scientific notation, if the decimal is, if the zeros are behind the decimal, then we know that we're going to have a negative exponent. So, I want you to try your best to solve this, and I'll present the answer after. And so you can pause it right now, solve it, and see if you got the answer correct. Oh, and remember, scientific notation. Yes. Okay. So the answer is negative 3.1549. Now, if you got this, you failed. JK will XD. You got it right, and you've got this quite well. You quite understand what you're doing. So, I'm very proud of you. Yay! Now, yeah, a good yeet to you because you've got this right. And good night, guys. It was awful fun being your teacher, even if I wasn't the best, but it was fun. So I hope you guys quite understand common logarithms now, and that'll be all. Good night.